Hello and welcome. Today we're going over 9.8 applications of logarithms. So if you deposit money into a savings account or any other type of investment, your money will grow over time. This is called compounding interest. It's also called time value of money. So here's an example. So investment was made of $5,000 into a savings account that pays 4%, which is 0.004. It's compounded annually. So when it says annually, that means, right, 1 year. How much money is the account at the end of 3 years? So since your money is growing, we're going to use a multiplier of 1.04. So it's 100% plus 4% every year. So you have 100% of your money plus 4% you're getting every year. So that's why the multiplier is 1.04. Because it's 1 plus the 0.04. So let's say you have $5,000. So what we would do is we would take $5,000, right, and times it by 1.04, and that would give us 5,200. Okay, then we take the 5,200 times it by 1.04, right, we get 5,408. And then you continue again, right? Multiply that by 1.04. You get $5,624.32. And you can keep doing that over and over and over. Now, as I'm going through these notes, please make sure you're typing these numbers in your calculator and getting the same answers. Don't just write them down because I'm writing them down. Making sure you understand how I'm getting these answers, that you're going to want to use a scientific calculator. So if you're watching the notes on your phone, you can turn your phone sideways on your scientific calculator. But you're eventually going to need a scientific calculator. So let's get an answer using a formula. So here's our formula. This is a very common one for compounding interest. So you need to understand what the letters mean, the variables. So A is the ending amount. Right? So, for example, the 5,200 would have been A. The principal investment is P. So, for us, in the initial problem, that would have been 5,000. R is the interest rate as a decimal. So, for us, that was 0.04. Right? The number of times interest is compounded per year. So, that for us would have been 1. So, example, annually is 1 time per year. Quarterly is 4 times per year. Right? Monthly would be 12 times. Right, because there's 12 months in a year. And then T is the number of years the money is invested. So for us, that would have been 3. So using this formula here, right, we want to figure out what is our initial or our final amount. So P is our principal. So we invested 5,000. It's always a 1. The interest rate was 0.04 because it was 4%. N is the number of times it's compounded per year. It was once. So then you have 1, and then T was 3. So how this works is in a calculator, right? First thing I would do is I would do 1 plus 0.04, right? So that would be 5,000 times 1.04 to the third power. So now, next step, I would grab my calculator. This is why you want a scientific calculator. I'm going to do 1.04 to the third power, and then I'm going to times that by 5,000. If you do it correctly, you should get $5,624.32. That should be what you get. So right now, you need to make sure you plug into your calculator and you get that answer. So pause the video, plug that equation in, and make sure you're getting $5,624.32. So hopefully you pause the video, you've come back now, and you got that answer and you understand how to put it in your calculator. Again, if I was plugging this in my calculator, I do the 1.04 to the third power, and then I times it by 5,000. That's how you would plug it into your calculator. Okay, example 2. So we're going to change the problem a little. So it's still going to be 4%, and this time it is compounded daily. So how much money would you have at the end of 3 years? So same formula, still investing 5,000. It's still 0.04, that's the interest rate. But now it's compounded daily, so every day. So that means 365. And then 365 times 3 years. Whoops, sorry, not 355, 365. Okay, so simplifying this a little. So we have 1 plus 0.04 over 365. 365 times 3 is 1,095. So now on my calculator, right, get my scientific calculator, I would first add 1 plus 0.04 divided by 365. Then raise that to the 1,095 power, and then times it by 5,000. So you do what's in the parentheses first, raise it to the 1,095 power, times it by 5,000. And if you do it correctly, you should be getting $5,637.45 if you're doing it correctly. So right now I want you to pause the video, take the numbers, punch them into your scientific calculator, and make sure you're getting that answer. So pause the video now and see if you get the same answer I got there in red. So hopefully you got the answer I got here that I'm boxing in red. Again, you should be doing what's in the parentheses first, raise it to the 1,095th power, times it by 5,000. You need to make sure you're getting this answer so that you can do it correctly on your homework and your quizzes and your tests. So notice there's a small difference between the ending amounts. Same percentage, still was 3 years. So this is explained by the number of times the investment compounds. So it was compounding 3 times versus 1,095 times. So that explains why there's a difference, right? Wait, go ahead and flip it over. So same type of problem. So the initial investment is 8,000. Okay. So it grew to become 18,303. It was invested at 6% semi-annually. Okay, so that means semi-annually, that means 2 times per year. So how many years was the money invested? We're still using the same formula. Okay, so this time, right, we know A. A is the 18,000. So 18,303.42. The principal, so this is P, this is A, is 8,000. Your interest rate, so 1 plus 0.06 because it's as a decimal. And I'm dividing by 2 because it's being compounded twice per year. And then this would be 2t. Again, remember, n is the number of times it compounds per year. So now I need to solve for t. Well, in order for that to happen, right, I've got to get everything that I can to the other side. So I'm going to divide by 8,000. So grab your calculator, divide by 8,000, right, and you should get 2.288. And this is 1 plus 0.06 divided by 2 to the 2t. So it's getting a little better, right? Got rid of the 8,000. Please make sure you don't round too much because the more you round, the further you get away from the correct answer. So you should be going out at least 3 decimals. So right now, we don't really have any way to figure this out. We could simplify this part here, right? 1 plus 0.06 divided by 2. If we divide that, add that together and divide, right? That gives us 1.03. Okay? So we can't divide by 1.03 because it's to the second power, or to the 2t power. right? It's kind of hard to rewrite 2.288 as the same base as 1.03. So our really only option right now is to go into log form. So we're going to change it to log form and then use our calculator. So to go to log form, this is my base, the 1.03 to 2.288 equals 2t. So they basically just switch spots. The base is always the same, right? The base of the exponent is the same as the base of the log. That will never change. What changes is the exponent and what it equals. They'll just switch spots. So the 2t and the 2.88 basically just switch. So now from here, right, I can use my change of base theorem and change it to base 10. So log of 2.288 divided by log of 1.03 equals 2t. So now I'm changing it to base 10. Why do I want to change it to base 10? Because that's what my calculator will do. So you can turn your calculator, if you have the phone, sideways, and you can do log of 2.288 divided by log of 1.03. Right? And then divide that by 2, and you'll get an answer of 14 years. So you take your log of 2.288 divided by log of 1.03. Right, on your calculator, you'll get a decimal, divide that by 2, and you'll get 14 years. So right now I want you to pause the video, and I want you to plug that into your calculator and see if you get 14. So log of 2.88, right? So divided by log of 1.03. Right, and then divide that by 2 and you get 14. So pause the video and do that right now. Okay, so hopefully again you got 14 years. Okay, the next one, continuous compound. So the formula is a little bit different. Again, A is still the final amount, P is still your initial investment, R is still your interest rate, T is still time, and then E is just our base value, V. It's always the same value. So the initial investment is $700, so that's P. It pays 3% interest compounded continuously, so that's R. Write an equation for after T amount of years. So A, the final amount, equals 700 to the E raised to the 0.03 T. Because again, the interest rate is always as a decimal. Right, how much will the investment be worth after 15 years? So 700, so 0.03, T would be 15. So I times 0.3 and 15, you get 0.45. Right, grab your calculator, do e to the 0.45. So I would do e to the 0.45 times 700, and you should get the final amount to be about $1,097.82 if you do it correctly. So $1,097.82. So grab your calculator and see if you get that answer when you type in the equation. So e to the 0.45 times 700 and see if you get this answer. So pause the video and do that right now. So hopefully you got 1,097.82. Again, you plug in e to the 0.45, times it by 700. So you do this first, then times the 700. Wait, how many years would it take the investment to double? Round your years to the nearest tenth. So double, well, that means we want to know when a is going to be 1400. So 1400, we want to know how many years that's going to take. So it's still $700, still 0.03. Now we want to solve for t. So again, I want to get t by itself, so I'm going to divide by 700 first. So we have 2 equals e to the 0.03t. Okay, again, right, it's kind of hard to write 2 as a base of e, so we're going to go into log form. So remember, when it's base e, right, we could write log e, but we usually just are going to use the natural log, so ln. So ln of 2 equals 0.03t. So your base is e. So remember, the e is always the base because it's the base of the exponent. And then the exponent and the 2 just switch spots. Again, log base e is the same thing as writing ln. So I would divide by 0.03. That reduces, and you should get what t is. So right now, on your calculator, you would type ln of 2, divide 0.03, and you should get about 23.1 years. So right now on your calculator, I want you to try that. So pause the video and see if you get 23.1. Do that now. So now, hopefully you got 23.1. You divide the ln of 2 by 0.03. Again, remember, if you wanted to, you could have wrote log base e, but that's the same thing as ln. And scientific calculators have the ln button, so just use that. So ln of 2, divide by 0.03, and you get about 23.1 years. So we have continuous compounding, which we use this formula there with the blue arrows. And then all our other compounding, we're going to use our formula here with the stars. Letters still mean the same, right? A is the ending amount, P is the principal, R is the interest rate, N is the times it's compounded in a year, and T is, again, time. The key is, a lot of this you're going to use your scientific calculator, and remember, when you're solving like example 3 here, or the last example here, when you're solving for time, you're going to have to end up going into log form, sometimes using change of base, sometimes you don't have to, in order to solve for the time. So anytime I ask you to solve for the time, you're going to have to go into log form. Make sure you answer the essential question at the top of the notes when you're writing your summary, and you'll be done. Have a wonderful day.